Instantaneous speed. The definition of instantaneous speed will be from a calculus perspective. So the instantaneous speed of a body refers to the speed of the body at a particular instant in time. That seems fairly obvious from the name instantaneous speed. So graphically, instantaneous speed is found by calculating the slope of the tangent line at one point formed on the graph of a function of a graph of distance versus time. So, at time value t, the formula used to determine instantaneous speed or instantaneous rate of change is the limit of f of t plus h minus f of t divided by h as h approaches 0, is the definition of a derivative, just with respect to time as a specific unit. So, an example. The function of the concept of free fall is y equals 16t squared feet in t seconds. Calculate the instantaneous speed of a falling object at t time equals 3. So, calculating instantaneous speed, so we're actually determining the speed of the object at a very, very small interval of time. So we'll write down our formula for this. So the limit of f of t plus h minus f of t divided by h as h approaches 0. So we'll plug in the numbers we have. So we have 16 times quantity 3 plus h squared minus 16 times 3 squared divided by h. So 16 times the quantity 9 plus 6h plus h squared minus 144 divided by h equals 144h plus 16h squared, divided by h equals 144 plus 16h. Okay, just a second. Equals 144 plus 16h. So, by utilizing smaller and smaller h values, which is really what this is saying, the limit as h approaches 0, so infinitely small values, increasingly small values. So when the tolerance of the h value, so when h is, say, 0.1, the instantaneous speed equals 145.6 feet per second. However, when the h value or tolerance is much more precise, say h is equal to 0.0001, the speed can be much more accurately calculated to be 144.00016 feet per second. So we'll look at another example. So the same kind of exact same situation, really, just a different time. So the function of the concept of free fall is y equals 16t squared feet in t seconds. Calculate the instantaneous speed of a falling object at t equals 6. So again, the limit of f of t plus h minus f of t divided by h as h approaches 0. So 16. So the function f here and f here is represented by y. So y is really equal to f. So when we put in t plus h in the function f, we're really putting t plus h into t here. So 16t6 plus h squared minus 16 minus f of t, so putting t in for the t value here in the function, so 16 times 6 squared divided by h. So this equals 16 times the quantity 36 plus 12h plus h squared minus 576 divided by h, 190, 192h plus 16h squared divided by h. This equals 192 plus 16h. So again, when we use smaller h values or smaller tolerances, we get more accurate results. So when h is equal to 0.1, instantaneous speed is 193.6 feet per second. However, when the h value is equal to 0.00001, we find that it can be more accurately calculated to yield 192.00016 feet per second.